Hello everyone, the Western Railway Museum is selling authentic retired BART train operator consoles sourced from decommissioned legacy cars. This is a once-in-a-lifetime opportunity to own a key piece of the BART legacy fleet. Every train in revenue service was controlled using a console. The train operator control console was used to operate trains in automatic and manual modes. These consoles are very different from the controls used in earlier 1900s subway cars. Gone are the stately controller, brake handle, and reverser of yesteryear. This is a new generation of train operation with computers, automation, and communications all wrapped into one. The Western Railway Museum is offering two versions, a C1 car, as seen here, and an A2 car using a C1 car frame. These differences will be explained shortly. Each console comes with an authentic dose of wear and tear. The console parts have been cycled through dozens of cars throughout the years, and the number inside them, if any, is the final C1 car in which the frame was sourced from. If it's a C car, it's very likely these parts were sourced from said car, while for an A car, the console pieces were sourced from a variety of A cars. For today, the two consoles were sourced from C car 306 and A car 1219. These consoles are being sold at $1,000 each. These funds will be used to support the preservation of their legacy fleet at the Western Railway Museum, the only museum to preserve the BART legacy fleet, and will be used to cover the transportation of 3 cars to the museum, provisions for public access such as a ramp and historical displays, possible restoration of 1 or more cars to the original 1970s appearance, and support the future Rapid Transit History Center. You can do pretty much anything you'd like to do with it. Hook it up to 36-volt DC power at your own risk, but the lights will still work. If they don't, they authentically don't work too. I plan on hooking up one of these to my BART model railroad. Quantities are extremely limited, and therefore the earlier you contact the Western Railway Museum, the better the chances of getting a console. Additionally, the WRM will do their best to provide you with a complete A or C car version, but cannot guarantee the availability of each part. If you'd like a console, you can reserve one by providing your name, email, and address, and your preference of an A car or a C car to the email consoles@wrm.org, consoles@wrm.org. I handle the inventory of this on a volunteer basis, so please be patient. The console costs $1,000, which will be paid after reserving one. They will be picked up at the Western Railway Museum. Alternatively, they can be shipped at the buyer's expense, which may be around $300, more or less. On to the consoles in more detail. For reference, this is the original train operator console. I am working on restoring it, and being the last of its kind, it is not for sale. Here is a picture of a complete one back in the day. This original console design was first introduced in 1970 and used on BART's opening day, September 11, 1972. It heavily reflected the ideas of BART's designers and having much faith into new technology. The train attendant, as they were known, did not even know the maximum safe speed generated by the ATC system for their very own train. After the Fremont Flyer incident, BART added signs showing the maximum safe speed and installed a panel providing the maximum speed and other pertinent information. The second generation consoles here, the ones for sale, were built with all that in mind. First up is the C1 car console. The C cars introduce a new design of train operator consoles, which is seen here. The console was an evolution of the original A car console, refined through several years of service and lessons learned, including those previously mentioned. These cars entered revenue service in March 1988. The last of these were retired in May 2023. On to the A2 car console. The A cars received a new console, which was similar to the C car console, in the late 1980s. Which coincided with the replacement of first-generation car-borne ATC equipment with second-generation equipment as installed on the C cars. They had the same communications panel as the original A cars, but with a new mount to fit the new console. By the 2000s, some A cars were rebuilt into A2 cars, and the rest were converted and rebuilt into B2 cars. The A2 cars had a new Annunciator panel, which is red. I'll walk through the consoles, starting with the Annunciator panel. On the top is the Annunciator panel, which provides the operator with a summary of the systems in a train communicated through train line and affecting 1 or more cars. This served as a starting point for identifying a problem. In order to locate the problem car, the operator had to check trouble lights in individual car control panels. So let's go to the Annunciator by Annunciator. Brake 2 is lit when dynamic and friction brakes are released. It goes out when brakes are applied. When brake 3 goes out, full braking, open loop, is applied. The command speed indicator in miles per hour displays the speed codes received from the running rail 0, 6, 18, 27, 36, 50, 70, and 80, which is modified by friction brake cutouts resulting in a full, reduced, or half speed. The speedometer, the actual speed digital display, may be lower than the command speed indicator due to modification by a performance level. The default is performance level 2 with a maximum speed of about 70 miles per hour, even if the command speed indicator shows an 80 mile per hour code. Brake on lights red when friction brakes or parking brakes are applied in one or more cars. The friction brakes light red due to any problem with the friction brake system. The dynamic brakes annunciator lights red due to problems with the dynamic brakes, which can include when dynamic brakes are applied in a propulsion mode on one or more cars. The bypass activated is lit when any bypass switch, such as flipper door bypass, door close bypass, or brake bypass is activated. Door open lights red when one or more car doors are open. The parking brake is set, the emergency door release handle is activated, or other related door conditions. The auxiliaries annunciator lights red when going through third rail gaps, or during the failure of an inverter, motor alternator, or APSI, depending on the car type, or other conditions such as low voltage or low air supply system for certain cars. Propulsion lights red when no propulsion is on one or more cars, systems or overload problem, potential reverser problems with certain types of cars, a propulsion fault, or dynamic brake problems. The dynamics and or propulsion cutout lights white when the propulsion and dynamics or dynamics only have been cut out in one or more cars. The handset is a push-to-talk handset with a receiver and transmitter. The communications control unit for C cars has a volume and channel selection. TT means train telephone, communicate with central control via the selected channel or radio control head. When TT is depressed, the overhead speaker is disconnected and the speaker in the handset provides communications to and from central. The audio transmission annunciator, trans, lights red to enunciate the TT button and when push-to-talk switch on the handset is pressed. TTPA, train telephone to public address, connects central control with the train's PA system. This can include delay updates, elevator updates, or safety announcements.
Good evening, passengers. Elevator update from the BART Operational Center. At this time, we have one elevator out of service at Balboa Park Station. Each station elevator is out of service again. Balboa Park Station. Elevators out of service.
This is sometimes called the Train Public Address, or TPA. Test is for the test mode for PA and intercom systems. PA, public address, activates the handset for announcements to passengers. The intercom button is a push button that activates the handset for communications from passengers pressing the intercom button. Release releases any communication function. Attendant signal provides a warning tone to the other cab for communication between cabs at opposite ends of a train. A cars had a different style of communications panel. They had an intercom volume knob, which controls the volume of the overhead speaker for the intercom, and an intercom hold button, which was used to place the intercom call from a passenger on hold to let the operator speak to central control or to make a PA announcement. Just for historical interest, here is a communications panel from a C2 car and one from a C1 car. As you can tell, there's a few differences. This includes having the selection for 6 radio channels instead of 4 on the C1 car, and repositioning of the release button compared to the C1 car. The C2 cars had a different button layout compared to the C1 cars due to the addition of the intercom hold button. As such, there were new positions for the release, the TPA, and the attendant signal buttons. The release button was on the bottom right corner instead of the bottom right middle as with the C1 cars. As such, many train operators drew an arrow to signify where the release button was. The LCD panel allowed the operator to monitor and regulate the operation of the train. The contrast knob adjusts the intensity of the LCD. It can also be turned completely off. The keypad has 16 keys to enter data or select a display. There is a chime to indicate the depression of the keypad for certain events, such as the automatic door release. This buzzer can be found inside of the LCD module. Train operators load the train run number, destination, half-rate acceleration, and the data log and time. The train length selector switch is set by the train operator to correspond to the number of cars in the train. The minimum train length on the main line was 3 cars. The train length verify, TLV, push button was depressed by the train operator to verify the train length before the train would move in automatic mode. The TLV also slowed down the train or could even stop the train. The NZSC non-zero speed command has 3 lights, LEDs, to indicate a non-zero speed command coming from the 2 online ATP modules. Some additional functions of the LCD was to alter the train's berthing in a station by stopping longer or shorter within the platform. It could also show the status of cutout cars and if the train would run at full, half, or reduced speed. The control panel, or utility panel as is better known, controlled various important functions including uncoupling, parking brake, lighting, horns, and for A cars, the aux-on and aux-off buttons. Uncouple X uncouples the car from the X end, the rear, and the uncouple Y uncouples the car from the Y end, the front. Reverse jog was used to move the car in reverse to separate 2 cars after uncoupling, and for stretch testing to verify a good coupling after coupling to another car. Parking brake on and off was used to set the parking brake. The defogger was used to turn on the defogger. Lamp test all Annunciator lights, and the console would also illuminate the speedometer to read 88. The reading light turns on the console reading light, and the inspection lights turn on the trackway inspection lights of C cars. For A cars, the map spot was used to light the left area of the console using the original 1970s overhead light. The aux-on and aux-off buttons on A cars were used to activate the train's auxiliary system, while the aux-off button deactivated the train's auxiliary system. The hold door close button commanded the doors to remain closed if pressed while entering a station. If it was pressed with the doors open, the doors would close. The air horn activated the YN pneumatic horn. This was used for warning personnel along the right-of-way. The electric horn activated the YN electric horn. In road manual, the tone was continuous, while in yard manual, the tone was intermittent. The manual control selector switch selected the mode of operation: automatic, road manual, off, or yard manual. Automatic for automatic mode. Road manual for moving at speeds of up to 25 miles per hour. Yard manual for moving at speeds of up to 10 miles per hour. The MCSS actually prevents the console from sitting down on a table. This can be modified, which will be explained in a later video. The A-car console has been modified. The C-car console has not been modified. The ready reset button was used to resume operation and used to reset faults in a consist. The stop button was used to stop the train in any control mode. The stop light lights red when the stop button was pressed to stop the train. It also turns on when changing modes and goes out when the console is reset. The DOA test was the door open annunciator test used while preparing the train for revenue service. The manual control handle was used to move the train in manual modes. The last part for discussion today is the right-hand door control. There were originally no right-hand door controls. For the original A cars, they had a button on the console. And these were added later. For the C cars, they did not originally have this box. The door controls were mounted on the wall behind the operator. The hinge window modification, which replaced the original drop sash window style, resulted in a new door control box, which is seen here. The cars with the original drop sash windows did not get a hole in the console. The A cars include a nice 1970s style door control box. The console measures about 26 inches wide, 14 inches from front to back, and about 12 inches tall, plus the door controls. It weighs about 35 pounds. So that is the console in full detail. I hope you are able to reserve one of these extremely limited and authentic pieces of BART history, which in turn supports the preservation of 3 complete cars at the Western Railway Museum. Once again, they are being sold for $1,000 with free pickup at the museum or shipping at buyer's expense. You can reserve one at consoles@wrm.org. Stay tuned for more BART legacy parts and updates to the preservation of the cars in the coming months.